installment of Computers with me, Professor Botanist Babbage III. Today we will be looking in a MATLAB perspective at data analysis and statistics. Now the first statistical function we will be using is the mean function, which is the central tendency of data, or exact middle, or average. This is the normal arithmetic for the mean function. To put in the MATLAB, you would just simply put mean parentheses what you want to find the mean of the array you're looking at. Standard deviation shows how much variation from the mean exists. This is the original, the ordinary math, not what you'll be putting in the MATLAB. We'll show you that later. Next we have the variance. Variance measures how far a set of numbers is spread out. Again, this is the equation. 1 over n minus 1 plus the sum of your x's squared. After that comes covariance. Now covariance is a measure of how much two random variables change together. Here is the arithmetic. Correlation coefficient measures the linear correlation between two variables x and y. This will give us a number, 1 being the best, 0 being the worst. It could be a positive number or a negative number. It's always mostly a decimal, unless it's 1. Let's say you want to know who the best Pong partner is. We can do a study using MATLAB to find out.
To find out who the best Pong player is, we created a function that reads in the array of Pong shots and the array of sodas consumed. First, in this function, we will plot the amount of Pong shots made versus the amount of sodas consumed. First, the function plots the scatter plot and labels the axes accordingly. Next, a nested function is created which takes both the two inputs and calculates the correlation coefficient between the two sets of inputted data. Another nested function is needed within the calc_core coefficient mine, which this function is named, to find the covariance, which is the strength of the correlation between two sets of data. The for loop here is used to find the mean of the x and the y arrays. The following for loop here is used to find the sum of the elements, the element of each array, the mean minus the mean of each array. Finally, the correlation coefficient can be calculated by the covariance of xy divided by the square root of the variance of x times the variance of y, which the equation is shown right up here in MATLAB syntax. This is a way to calculate the covariance, the correlation coefficient between. This is a way to calculate the correlation coefficient without using intrinsic MATLAB functions. Here I will show you what happens when we run this function, which is called VT9. And here's the first scatter plot. This is the correlation between the amount of sodas consumed versus the shots made. The correlation in this plot seems to be a negative low correlation. And the correlation coefficient we received was negative 0.6595, which is a pretty low correlation.